Welcome back to the Nutanix Community Podcast with Dwayne Lessner and Angelo Luciani. Let's get started. This week on the podcast, Dwayne chats with Kees Baggerman. They discuss end-user computing, performance, and AMD Nodes. It's packed with information, so get comfortable and let's join the conversation.
Joining us today, we have a podcast legend, as it were. I would almost gather maybe 10 plus years doing podcasts, even more doing VDI. Welcome to the show, Kees Baggerman.
Hey, thank you, Dwayne. How are you doing?
Pretty good. Yeah, I think early on in our Nutanix careers, we probably spent a lot of time together, but we haven't lately. So, what have you been up to?
Oh man, there's so much going on and so much innovation that we try to help drive. That it's obviously Nutanix has always been a company that kept us busy, but the whole pandemic and the kind of the drive for innovation is keeping me and my team busier than ever.
Yeah, I get asked, around where I live is oil country, so. That it's not been really great from a job perspective lately, but always luckily I have a job. But, people like with the pandemic is your company busy? And I'm like, well, you're almost kind of shy to tell them, well, we are busy. but EUC is probably one of those reasons that, more people working from home has definitely helped us that way.
I agree. Yeah, I think that if you look at kind of the time frame, we saw a lot of traction, kind of the first few months, maybe first few quarters, where people were kind of patching and making sure that everybody was able to work from home and have something to be productive. And kind of later on, all of those discussions kind of transformed in a different style of discussion where business continuity and DR became a hot topic because, when you have everybody working from a remote location and there's such a big focus on that centralized virtual desktop environment, then you want something to be able to do DR or business continuity as well, right? So discussions are changing, but all for the good, because I think that a lot of companies have kind of realized that end user computing is a tier one application, business critical, as we would say. All kind of good developments from that side.
Now you're CTP. I don't know if you're still the expert. You did the Frontline Chatter podcast for a long time. You're doing EUC Digest. What after years of doing VDI, what remains most important to end users today?
Well, I think that's a good question, and I think that it's not so much for end users per se, but if you look at the customers and the prospects that we try to help, it's definitely a combination in finding the balance between maximum density and the most optimal user experience, right? And what we're seeing is that there's a lot of demand from end users in terms of what they can expect from their systems. If we look at devices that people own at home, they want that simplicity, they want that speed, they want to have that access anywhere, anytime. And from a corporate IT perspective, we want to maximize the investments that we have done in the past and in the near future. So there's a constant kind of struggle between delivering what the end user wants, and in the end, that's a reliable, secure, fast access to their core applications and their line of business applications. And on the other side, you have corporate IT wanting to supply secure, fast, and reliable access as well, but also maximize on the investment and get the most out of the systems that they have in place.
So with that, what's new or different? I know that you've been working hard on testing the new AMD processors with Nutanix. What does anything change? Does life get easier? Because my experience when I was doing lots of EDI was that it was like a complicated math formula that you had to, not only did you have to know what you're doing, but it was kind of like an art, to get the sizing right. It wasn't easy by any stretch.
From a job security perspective, I would still say that it's black magic and voodoo. But if we look at end user computing as a kind of a concept overall, it has a couple of important metrics to be measured. I think disk latency is one of them. So how fast are your writes and reads from your VM to the actual storage? Because if you go up too high in disk latency, you will notice sluggishness in the desktops. Now that's something that traditional end user computing has been struggling with for a while. There's disk capacity, which is a kind of an easy metric because we know how much disk we consume. So that means that we know how much disk space we need in the overall solution. There's RAM, just plain old memory. And obviously there's a little bit of innovation on that side as well. But overall, RAM is pretty straightforward as well. And then there's CPU. And CPU has kind of been a metric that we've been struggling with as an industry because it's very hard to grasp, right? It's not a very predictable kind of metric to work by. Where use capacity or needed capacity from a storage perspective is pretty straightforward. It's measurable. It's something that we kind of can do a guesstimate up front. And if we deviate 10 or 12% or maybe 15%, it's not really hard to kind of adjust that. But from a CPU perspective, it's much harder to get that right. And, if we look at what Nutanix has been doing overall in the last few years, and Dwayne, I vividly remember the time and the places where we worked together to make this happen. But if you look at these three things, especially the storage the storage layer, I think that Nutanix has solved that issue ever since the inception of the concept of HCI. So storage latency is typically not our issue. In all of the testing we've been doing, we never see that we run out of I/O or that the latency goes up too high, which renders the solution unusable, right? So from a storage perspective, if you stick within the 0 and 5 milliseconds latency, then you've got a perfect user experience. Anything higher doesn't or anything lower doesn't really make sense. So if you go into the sub millisecond latency, doesn't really make sense because if you look at the workload itself, if you look at end user computing, there's a thing called protocol round trip times. And basically what that is when I click on the screen from my endpoint. So I'm based in the Netherlands near Utrecht, and our closest data center location is based in Amsterdam, which is still the Netherlands, but it's 200, no, not 200. It's like 60, 70 kilometers apart. But when I'm at home,
5 milliseconds latency. Typically,
it's a little bit more. It's like it's the round trip time. So it means that when I click on my endpoint in a virtual desktop, that kind of signal needs to traverse the network to my data center and back for me to actually see the update on the screen. And that's what we call protocol round trip times. And that from my desktop to Amsterdam or from my physical location to Amsterdam is about 23 milliseconds latency. So we can shave off all of the latency on the back end. But if my packages are not reaching me in time, I won't ever see that kind of the benefit from that lower storage latency, right? So, and that's why for end user computing, we don't typically need all flash systems. We can do it with hybrid systems, but if you want to go all flash for future's sake, then by all means do so. But from a storage perspective, performance-wise, we don't really need all flash or NVMe drives for that matter. This capacity. Go ahead.
No, just regardless of how big the desktop is, there's probably a giant chunk that's just sitting idle or not used, just like a file server would typically be.
Yep, exactly. So that leaves this capacity is pretty easy and straightforward to calculate with. Same goes for RAM. the typical desktop is somewhere between 4 and 8 gigs. Like that's if I sum it down, it's somewhere between that. If you know how many desktops you can run on a system, you can multiply that by the RAM you want to assign per desktop. You take a reservation for our controller VM and a little bit overhead of the hypervisor, and you're good to go. But CPU, as said, it's always. Oh, go ahead.
Yeah, on the RAM thing, that one thing that's I've seen lately, and I think it's because of public cloud vendors, is that people want to right size their workloads. And I ask them, is like, would you want a desktop? Like, say you needed 4 gigs of RAM, would you want to use a desktop that's only 4 gigs of RAM? Like when I look at my machine, it starts to get slow. It's like, it's slowly like 60-70% utilized. It is a dog. you know, it's like, you need a lot of free RAM for Windows to work properly. At least.
Absolutely.
Yeah.
And you've got applications that are chewing up RAM like crazy. If you just look at Chrome or any of the browsers, right, they chew RAM like it's breakfast. So it's good to have a little bit of additional RAM in the system in order to make it performant. Again, somewhere between 4 and 8 is kind of where I see the industry right now, and it's a broad scope, but that's the majority of the desktops are sized like that. And you know, if you look at CPU, like I said, it's always been a hard metric to capture, and especially if you look back a few years where we had CPUs with a relatively low amount of cores, densities were relatively low. And now with kind of the testing that we're doing with AMD, we're seeing a massive jump in terms of density and performance altogether, and that's something that I love to talk about, because that's, for me, that is fundamentally changing discussions with customers as well.
What are you talking from a core count perspective?
Right. So, if you look at the nodes that we've tested in our lab, those are HPE DX 385s with 2 CPUs and 32 cores each. So that makes a total of 64 cores without any hyperthreading or whatnot. So they're very high dense, very powerful CPUs as well, because besides the fact that they're that there's a high number of cores, the clock speed of these CPUs is still 2.9 gigahertz. So if you have single-threaded apps in your environment, and I guarantee you, every environment that's out there right now has single-threaded apps, and especially in the finance world and healthcare world, those high clock speeds will definitely help you in terms of performance, and will make lives a lot easier for end users, because instead of forcing all of the traffic over a very small country road, now all of a sudden you have this 4-lane highway that you can fully utilize. So the combination of a lot of cores and high clock speeds is definitely something that helps drive user experience.
Yeah, I'd always be happy with something faster. That's for sure.
And I guess that AMD came out with their new Epics. Intel kind of responded with the Cascade Lake refreshes, and those were really good CPUs as well, right? So if you look at the Intel ones, you can get 2 times 20 cores at 3 gigahertz, or 2 times 24 cores at 2.9 or 3.1 gigahertz. Those are decent core counts and decent clock speeds, but the AMDs, and I guess that's kind of the tipping point for me. So we did a lot of testing with these AMDs, and when we started off, if you look at the configuration that we have, it was like I said, a DX 385 with 2 times the Epic 7542 running at 2.9 gigahertz. We had 8 nodes. All of them had 1 terabyte of RAM, 2 SSDs, 10 spinning disks. And what we saw in our first initial testing was that we could host up to 360 users, Windows 10 Knowledge Worker with log and VSI, sized at 2 vCPUs and 2.5 gigs of RAM. And that's just an insane number, right? But that being said, that is the login VSI max. So that's the maximum number of users that you can host on the system before you start impacting the user experience. Now, typically, we want to be under that 100% because nobody wants to run their servers smoking hot at 100% CPU because things will start falling over. So what we typically tend to do is take a step back and move to about 80% of CPU utilization, because that way we're still comfortable in terms of what the system can handle. If there's a peak, if there's a period in time that the desktops are requiring a little bit more CPU, then we still have the headroom on that host to actually do that. So we tested with 2 vCPUs and 2.5 gigs of RAM and got that insane number. And basically what we did is we took a step back and looked at the horsepower that these systems have, and we actually went on and tested with 3 vCPUs. And we got to 235 users, again, Windows 10 knowledge worker profiles on a single node. And that number for me is so high that it shifts the discussion. And it shifts the discussion. Oh, sorry, Dwayne.
No, I was just going to agree with you. I think, you know, the amount of desktops is quite high, but I think you're getting there. I think with for what I having to maintain an environment, it's nice to see large numbers, but not for the sake of having the large number. But for me, I want to be able to maintain this thing. So that is
Absolutely.
Yeah.
Yeah, and that's kind of the point that I was going to make. Indeed, you're spot on. It's great to have these high numbers, but in kind of the overall solution, you need to be able to manage the environment, and also you probably want to minimize your failure domains, because having 250 or 230 users on one box is great from a corporate perspective, and people will probably love it for their density and the cost perspective that comes with it. But when a host goes down, you potentially have 235 people on the phone saying that their desktop isn't working anymore. So that is a fundamental shift in the discussion with customers and prospects, that instead of having that discussion of how many users can we cram onto this box until we have to buy a new one, or in larger cases, what kind of building blocks are we building to make sure that we can maintain that kind of a repetitive model in these large scale environments. Now, all of a sudden, we have to change the discussion in, dear Mr. Customer or Mrs. Customer, have you ever thought about your failure domains? How big would you allow your failure domain to be? How many users do you want to host on that single node for you to be comfortable when there's a node failure? And that's something that I haven't seen a lot in the conversation with my customers. Have you seen that a lot, Dwayne?
You know, to be honest, lately I haven't done too much in VDI, but I've never had the luxury of asking anyone to hold 700 desktops in one node before. So yeah, it's kind of crazy on that side, but I just know I would sure love to like move 100 desktops to like move 100 to between 5 servers instead of trying to, you know, move all 700, you know. It's crazy how easy it would be having to wait for a vMotion to finish before you can do an update.
Yeah, definitely. If you think about that, if you need to do vMotion and or live motion or whatever kind of the technology stack is that your hypervisor supports, all of that obviously impacts the overall system as well, right? So if you're moving, let's say 100 desktops at a time or 150 desktops at a time, it's a very different metric than moving 300, 400, or 500 desktops at the same time. So it all kind of. So it starts with density on that host, and then it kind of waters down to management, to comfort levels, to SLAs and whatnot. And again, I think that as Nutanix, we broke the barrier of storage. We broke the barrier of storage latency RAM was always pretty straightforward, and now together with in this case AMD, we're breaking the barriers with on the CPU side as well. So I think that allows us to have a much better conversation when it comes down to end user experience, because in the end, I think it all comes around to end user experience, right? How I'd love to get a high dense environment, but in the end, if my desktop is not performing, I can throw all the money at that system that I want, but in the end, it has to perform for that end user. They have to accept it, otherwise they won't start using it.
Does anything change on the licensing side? I think VDI usually has its own licensing model, which tends to work out well, but I'll ask the question just in case there's any bugaboos.
No, and in fact, if you look at the way that we as Nutanix are licensing, so from a broker perspective, it's always CCU or named user, right? So it's always concurrent usage or named user, which is irrelevant to the hardware platform that lies underneath. As Nutanix, we have multiple licensing options, and one of them is VDI Core, which is very much aligned with that concurrency model that these brokers will have as well. So from that perspective, if you have a Citrix environment or a Horizon environment or a Frame environment, you can actually license as many desktops as you have on the broker side, on the basically the infrastructure side as well, and you're good to go there. So it doesn't have to change anything. Now, if you're a more traditional licensing model with CBL, then higher core counts might impact your licensing. But again, if it's for a VDI play or an end user computing play, VDI Core as a licensing model makes absolute sense to align perfectly with the licensing that you would have on the broker side.
Did with the added horsepower from the CPU, do you see the densities rising if everything remained the same? Or I guess I'm not really sure how to ask the question, but what I see happening is just advent of more security products sitting on the actual desktop. I
think it's it one follows the other, right? I mean, if you look at let's take a step back and think about your personal devices. Personal devices have become increasingly heavier in terms of the workload that they can run. And I guess between you and me, my first computer was a Commodore 64. It had limited capabilities. Now my kind of go-to device is my iPhone. I think I do most of my work on my iPhone. And that thing, compared to that Commodore, is just crazy in terms of horsepower and what it can do. But so as we go, me as an end user, I'm becoming more and more demanding, and I'm requiring devices that will fix that or suit that demand. So I think you're right. So I think you're right when it comes down to security, when it comes down to AV, when it comes down to applications that run inside of that desktop. It's an everlasting kind of race against applications that are poorly written or just consuming more resources on the system side, because we want to deliver that UX that we want to deliver to that end user, because they're used to that kind of Netflix or Amazon Prime experience in their home situation. So you want to deliver similar experiences on the enterprise side as well. And what I'm seeing, just to add to that, on our portal, there's if you go to portal.nutanix.com and you go to the support portal, there's like in the hamburger menu, there's a little item called solutions documentation. You can find a Windows 10 analysis or impact analysis document there, which was written by Sven Huisman, one of the architects on my team. And what we're showing there is basically the impact that just Windows has from one version to another. And we're trying to help you in terms of getting insights on what changes from one Windows 10 version to another. And even just Windows, right, has a different kind of resource consumption model from every build on. So if you're at 1909 right now, and you're looking at 2020 H2, you might be in for a surprise because those two behave very different in terms of the CPU that they consume, the RAM that they consume, and potentially the disk as well. So having all of that information makes for a better prepared migration to this newer version. So having that little bit more of oomph ready in the system, if you go for a Nutanix AMD system, provides you a better kind of future-ready state for different Windows versions and new security agents and whatnot.
Yeah, the extra headroom for the inevitable, whatever the next Spectra or meltdown ends up being.
Exactly.
It's going to happen. It's almost the inevitable, but. Yeah, I think that's really awesome. So we have support for Intel, AMD. We're seeing higher densities, but overall getting to a place where, things failing or operations is just becoming easier. And I guess that's like I think Nutanix has been successful on making life easy. And so hopefully, it's still transitioning down. But I do have one last question, and you're only allowed a minimum of 10 words to answer. Persistent or non-persistent desktops?
It depends on the situation.
I knew I wasn't going to get it. Just a one-word answer.
No, I'm all right. Let me rephrase. I'm Dutch, so I would say non-persistent desktops.
I like it.
Do you want my explanation as well?
Sure, go for it.
All right. So what I'm seeing, and this is kind of my what I'm seeing across kind of the different regions that my team supports, right? So we're a global team. So that means we'll support the US, EMEA, and APJs. And the major difference, there's two differences when it comes down to end user computing between Europe and the US. One is the US does a lot of published apps and uses RDSH, XenApp, server-based computing for published apps a lot, and only reverts to VDI for desktops. In Europe, we tend to do a lot of RDSH, server-based computing, and XenApp, whatever name you want to use, for published desktops as well. And that's non-persistent by nature. So that means that we tend to invest a lot of time in UEM products, in application virtualization, in all of that. And our deployments are typically a little bit smaller than the US ones. So what I see is that in the US, people start with persistent desktops just to get things started. And in Europe, we tend to invest a little bit more time up front to make sure that we have everything nailed down in UEM, user environment management, and application virtualization. And thus, we're able to do non-persistent desktops a little bit easier than in the US. So, there's my explanation to that.
All right. Well, it's all good. I just think it's better overall. Yeah, but it does require a lot of work up front to get right. But as we're leaving today, why don't what's next on the EUC podcast? What's on the agenda looming over in your world?
I think the previous one was around the launch of the RTX boards with NVIDIA. We blogged about the performance that we get with the RTX boards. This one was around the AMD systems. I think the next one will be around files, FS Logics, and end user computing.
Nice. It's funny actually to see what's left of the companies from 8 years ago around VDI, what's actually broken through or stand the test of time, because there's a ton, especially on the storage side, that never made it. So, if they're still being talked about today, you're probably in a pretty good place.
Oh, absolutely.
All right. Well, thanks for your time. Appreciate it. I think this one has been a really good podcast around VDI knowledge, a little bit of history, but more importantly, some new tools that should make people's lives easier. Thanks for coming today.
Hey, thanks for the invite, Dwayne.
I hope you enjoyed that. It's always nice to hear from Kees. Be sure to check out the Nutanix community at next.nutanix.com. That's where you'll find our community blogs, discussion forums, user group information, and training and certification news. So with that, from your friends here at Nutanix, have a great week.